So previously I said that the video talking about compound interest was the most important video this week. This comes in a very close second, again because we're going to be using it often, including next week, because next week is just a continuation of what we're learning this week. So this week is sort of the basics. So make sure you know how to transfer back and forth or convert between logarithmic and exponential forms. We're going to do a lot of practice. I'm going to give you a lot of different properties that we can use, and then next week we're going to be using them again and learning a few more. So again, this is we haven't really looked at logarithmic functions yet, but again, that's that button on your calculator that's either log or ln. So this is the log function, this is the natural log function. Same idea, just like we had an exponential function that was like 2 to the x, or an exponential function that was e to the x. These babies will kind of go together, and these babies will kind of go together. And that will come into play once we start learning more about them. So essentially what you need to understand is that I can write an exponential function as a logarithmic function and vice versa. So if I have a logarithmic function that looks like this, then I can write that as an exponential function. And there's really no specific terminology for what that process is, and so I of course call it the Swirly method because that is super scientific. But essentially I call it the Swirly method because what I'm going to do is I'm always going to start at the base, and the base of a log function is this guy right here, the b, and then I'm going to swirl across the equal sign, and then I'm going to swirl again. That is why I call it the Swirly method. So to rewrite this function as exponential, I would say b to the y equals x. That's how I swirled. b to the y equals x. So notice the log goes away because I'm rewriting it as an exponential function. I can do the same in reverse, again starting at the base, and just keeping in mind that the base is always the base. So the base here is the b, the base here is the base of our exponent. The base is always the base. So if I'm starting at I'm still following these instructions, I'm going to say, because it's a log function, I'm going to say log of the base, so log base b of x equals y. And notice that is exactly where I started. So let's do two practice together, one in each direction. So if I'm starting at x equal log 7 of 22, so that's log base 7, I always start at the base, so I'm starting at 7. I'm writing it in exponential form. So 7 is now my base of my exponential function. 7 to the x equals 22. And if you want to add an equal sign, because you're going to add an equal sign after you swirl across the x, you can certainly say that. Same thing in reverse. The base is always the base, so I'm starting at the base. I'm saying log base 14 of 227 equals x. Done. So just remember to swirl it. So what better way to just get this down than to just practice. So let's practice together. We're going to swirl. Remember, base is always the base. I'm writing these in exponential form. So I'm starting at 5. 5 is the base. I'm taking it to the negative 1. 5 to the negative 1 is 0.2. That's how I would rewrite that. Second one, a little tricky because we haven't talked about this. This is called a common log. So whenever you see a log function but you don't see what that number is as the base, the common log has a base of 10. So they're never going to write the 10, they're just going to assume that you know that. So when I write this one, I'm saying 10 to the 0 equals x. And then you can see how this is going to transfer into us actually solving this function and saying, hey, anything to the 0 power is 1, so x must be 1. You get the idea. Same thing with natural log. We haven't talked about this, but a natural log function always has a base of e, because a natural log function goes with a natural exponential function. So this one would be e to the 9 equals 5, which is not the case, but I'm just giving us one to practice. Now let's go in reverse. So the base is always the base. Remember, I'm writing it as a log, so you can always start by writing log, and then the base is going to be 5. So 5, log base 5 of 125 equals 5. Oh, I'm sorry, equals 3. I swirled too far. Equals 3. So the base stayed the base, and then I swirled and swirled again. Same thing here. I can write my log to start with. The base is 216. Swirl over to 6. Swirl over again to 1/3. And last one, again, because it's e, I'm not going to write log. I will never write log base e, because log base e doesn't exist. We just write natural log, because that is the log base e. So natural log of 4 equals x. So good practice. So now that you are an absolute pro at converting, press pause, try all 6 of these, then press play to see how you did. All right, first one, 3 to the 4 equals x. And again, we could solve that. We're not going to do that right now. X to the 1 equals 14. What's going to happen here? The base is e. Whoops. So e to the x equals e. And again, we could probably solve that one pretty easily. Going in reverse, remember that the base is always the base. The base is this guy. So log base 2 of 64 equals x. Log base x of 1/2, whoops, that did not look like a base. Log base x of 1/2 is equal to -1/3. And lastly, natural log, because again we're dealing with e, of x equals 2.